Now, what is the first derivative test? The first derivative test is a test or a process using the first derivative of a function to determine the function's extrema. Now, if you don't know what extrema is, there are two types, absolute and relative. Absolute is the highest/lowest minimum or maximum over an interval, and relative is the highest, maximum, or lowest minimum value of the numbers around it. So there are a few simple steps to the first derivative test. Step one is obviously find the first derivative, or f prime of x, which is just the derivative of the function you're trying to find the extrema for. And then step two is determine critical points. So critical points are values where the derivative equals 0 or the derivative equals undefined. So step three is find intervals of increasing and decreasing. And as you see later, we will be doing that with a sign chart. And then we are going to determine extrema using the previous step. We will find the points where the function changes direction and then plug that into f of x, the original function. So now let's apply this to an actual problem and maybe you'll make more sense of this. So for our first example, we are given the function f of x equals to x to the power of 4 minus 2x squared. So first step is find the derivative. So f prime of x equals to 4x cubed minus 4x. And from there, we're going to factor that to get 4x, x squared minus 1, and that equals to 4x, x minus 1, x plus 1. That leads us to our second step, which is finding the critical points. And here, there are no points which makes the function undefined, but we do have points where it makes the function 0. So that obviously be x equals 1, x equals negative 1, and x equals 0. So these are our critical points. And now we have to find out the intervals of increasing and decreasing. And to do that, we make a sign chart. So a sign chart, you basically just draw a line. You draw a line and you put your critical points on this line in numerical order. So first would come negative 1, and then would come 1, comes 0. So to find the intervals of increasing and decreasing, you're going to just plug in any values between these numbers into the derivative to find if it's positive or negative. So for this one, if we plug in, say, negative 2, if we plug that into the equation, I'm just going to do it as an example, but I won't be doing it for all of them. It'd be negative 8 times negative 3 times negative 1. So negative, negative, negative makes a negative. So from negative infinity to negative 1 would be negative. So you just draw the sign above here. So from negative 1 to 1, we need to plug in, say, 0. So when we do that, we get that it's the intervals of increasing and decreasing. And to do that, we need to make a sign chart. So you draw your line, and you put your critical points on this line. So we have -1, 0, and 1. So here are our intervals. We have -∞ to -1 here, -1 to 0 here, 0 to 1 here, and 1 to infinity here. So what we have to do is we need to plug in random numbers between these intervals into our first derivative to find if it's positive or negative. So for example, if you take -2, when we plug it into the equation, it's negative, negative, negative. So it'd be -8, -3, and -1. So negative, negative, negative equals negative. So it's a negative here, and we can plug in like -1/2. And when we do that, we get that it's positive. We plug in 1/2 here, we get that it's negative. And if we plug in 2 here, we get that it's positive. And with time, you can easily do this in your head and get the sign in your head, and you won't have to write it down on paper and plug it in this way. Yeah. Stop it. So the next step is finding the intervals of increasing and decreasing. So for that, we need to make a sign chart. So for our sign chart, we draw a line and we put our critical numbers on that line. So we have -1, 0, and 1. And we need to figure out if the function is increasing or decreasing between these intervals. So let's just identify our intervals first. So we have -∞ to -1 here, -1 to 0 here, and 0 to 1 here, and lastly 1 to infinity here. So what we're going to do is we're just going to plug in numbers between these random numbers between these intervals into the derivative to find if it's negative or increasing or decreasing there, or negative or positive. So for example, a number in this interval would be -2. So we're going to plug it into the equation to get -8 times -3 times -1. Numbers don't matter, only the signs. So we see that it's negative, 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 and that equals negative. So it's decreasing from -∞ to -1. Now we're going to do the same thing for this interval. Say we plug in -1/2, and we get that it's positive. So it's going to be increasing from there. We plug in 1/2 into this. We get that it's negative, and we plug in 2, and that will be positive. So it's increasing, decreasing, decreasing, increasing, decreasing, increasing. Stop it. Okay, so we can identify that our intervals of increasing are -1 to 0, since it's positive here, or this is the notation for or 1 to infinity. And our intervals of decreasing are -∞ to -1, or 0 to 1. Stop it. So now we know that at each of these critical points, the function is changing. So that brings us to our next step, which is plugging the critical points into our original function. So let's start with -1. So f of -1 equals to -1 to the power of 4 minus 2 times -1 to the power of 2. And this equals -1. Then we have f of 0 is equal to 0 to the power of 4 minus 2, 0 squared, which is just 0. And then f to the power of 1, which is 1 to the power of 4 minus 2, 2, which is -1. So now we have our points. We can determine that our points would be -1, -1 here, 0, 0 here, and then 1, -1. So these would be our extrema. But if we were asked to find the absolute maximum, that would be 0, 0, because it's the highest point out of all three of these. If we were asked to find our absolute minimum, there are no absolute minimums because these two are at the same y value.
Is that it?
Mm-hmm. So these two would actually be relative minimums. So here we have our next example. F of x equals 5 minus 6x minus 3x squared. And it's asking us to find all local minimums and maximums. So the first step is, of course, finding the derivative. So f prime of x equals to negative 6x minus 6. Our next step would be to find the critical points. There's only one here, and that would be So now we're going to go on to our next step, which is making our sign chart. So we have our line, we add our one critical number to it, which is negative 1. And let's just identify our intervals. This is negative infinity to negative 1. And this is negative 1 to infinity. So now we plug in numbers in these intervals to find if it's negative or positive. So let's just plug in negative 2. This is a negative times a negative, so that's positive. So it's increasing here. Then let's plug in, say, 0. We get negative times a positive, so that would equal to negative. So we get that it's increasing from negative infinity to negative 1 because it's positive, then decreasing from negative 1 to infinity because it's negative. So now we know that the function is changing at negative 1, so we can go on to our fourth step of plugging it into the original equation f of x. So we get f of negative 1 is 5 minus 6 times negative 1 minus 3 times negative 1 squared, which is 5 plus 6 minus 3. 11 minus 3 equals 8. So we get negative 1, 8. And since we know that it's increasing and then decreasing, it's a maximum. So this is a local maximum. And we can determine that there are no local minimums. So our final example is f of x equals 2x cubed plus 3x squared minus 12x. So for our first step is finding the derivative. So that equals to 6x squared plus 6x minus 12. We can factor the 6 out, so we get 6 equals 6 times x squared plus x minus 2. And this factors out to 6x minus 1, x plus 2. So next step, identifying our critical numbers. That would be x equals 1 and x equals negative 2. Next step, making our sign chart. So we have 1 here, negative 2 here. We have negative 2 here, 1 here. And let's plug in negative 3. It's negative times negative, so that would be positive. Let's plug in 0, negative times positive, negative, and then 2, which is positive times positive, which is positive. So next we know that the function is changing at these points, so we're going to put it into our original function. So we have f of negative 2 equals to 2 times negative 2 cubed plus 3, negative 2 squared minus 12 times 2. This equals This equals 2 times negative 8 plus 3 times 4 minus 12 times negative 2, which equals to negative 16 plus 12 plus 24 equals to minus 4 plus 24, which is equal to 20. So now we're going to plug in 1. So f of 1 equals 2 times 1 cubed plus 3 times 1 squared minus 12 times 1 equals to 2 plus 3 minus 12 equals to 5 minus 12 equals to negative 7. So the point here is negative 220. Here is 1, negative 7. So we can identify that our, can you stop?
Yeah, I'm recording that.
Yes, I am. So we can identify that our relative max is negative 220 and our minimum is 1, negative 7. So why do we do the first derivative test? The obvious answer is to find extrema. You're basically doing all these steps to get the end goal of finding the extrema of a function. And another thing you can use it for is also to find where the function increases or decreases, as well as find the critical points.